Hi everyone, my name is Maibel Brito. I am a Kaiser student, and today my presentation is going to be based on grids. This that I'm holding here in my hand is actually a grid. This is a device that is used and it has a great impact on image quality. The reason why is because it reduces scatter. Scatter to us is considered unwanted because of the fact that it can produce fog to our image. Scatter is produced by the patient's thickness. This device, this grid, will help us in removing those low energy class photons, therefore producing a higher quality image. I'm going to be explaining in more detail about this device through this video presentation. Experts in the early 1900s were discovering that the images were becoming blurred due to scatter radiation. But it wasn't until 1913 a German radiologist named Gustav Bucke invented the grid, which he placed between the patient and the IR. Because a grid is used to absorb the unwanted scatter, it is important to use a grid when the patient has a thicker, larger body part or with procedures that require a high kVp technique. In other words, a grid is used when the patient's body thickness is greater than 10 centimeters or when more than 60 kVp is applied. The grid is made of radioplaque LED strips that alternate with radiolucent interspace, composed of aluminum or plastic fiber. The reason they decided to make the LED strips of lead is because lead has a high atomic number and it has the ability to absorb scatter. This is the table Bucky, and right here we'll put the IR, but this part right here is actually part of the grid. The grid will go in the middle right here under it, and the grid is gonna go in between the table and the actual IR. A grid can move in either of the two ways during an exposure. One way is oscillating, which is in a circular motion, or in a reciprocating way, which is back and forth. This is an example of the grid moving in a reciprocating way. I'm gonna go over upside down grid errors. Let me just turn on the light here. So when we place a grid on top of the IR, you're supposed to place it with the label side up. But what happens is that sometimes the radiographer tends to work too fast or just unintentionally without noticing, and they'll place it upside down. So I'm gonna show you guys today how that will look. Let me turn off the light. So we have it here very centered in the middle. We're gonna go outside. And we're gonna expose. So now we're gonna develop that image. This is how that image looked. But what happened here was that because it was placed upside down, the label part or the grid, we have this dark shade in the middle and we have the lighter shade on the side. That's what occurs when you place a grid upside down. An off-level grid error occurs when the tube is angled across the long axis of the LED strips. This usually occurs with improper tube or grid positioning. Improper grid position most commonly occurs in stationary grids when used for mobile procedures or for decubitus views. It is important for the radiographer to align the tube correctly with the grid, because otherwise this will result in an unwanted absorption, which will decrease the whole exposure of the film. An off-centered, also known as an off-axis or a lateral decentering grid error, happens when the X-ray tube is not centered to the central axis of the focus grid. An off-focus grid error causes the exposure on the outer edge of that image to be lost because the SID is outside of the recommended ranges. The more effect grid error happens with digital image receptor when the grid lines are captured and scanned parallel to the scan lines in the image plate readers. This produces the zebra pattern. So So now we're going to speak about classification of grids. Grids are classified into different ways that they're built. The first one I'm going to go over, it's going to be the crisscross or criss hash grid, which is like this. This one is a crisscross or crosshatch grid, and basically the lead strips, they lie at a 90-degree angle. They built this grid in that particular way so that the lead strips are all perpendicular to each other. The next one I'm going to go over is going to be the linear parallel, which looks something like this. This is the linear parallel. And basically in this one, the lines never intersect. The last one I'm going to go over is going to be focus grid, which looks something like this. The focus grid is going to have parallel lead strips in the middle, and then it's going to have slanted, angled lead strips on the side. The reason why they built it this way is because the X-ray beam diverges. The reason why in the middle is parallel to each other is because of the central ray is going to hit right perpendicular to it. And then I'm actually exaggerating this drawing. It's going to be a lot smaller, like the slanted and also the parallel lines are going to be very close to each other, but I'm just exaggerating it for the purpose of this video. The air gap technique is an alternative scatter reduction method. As we are aware, the best way to improve our image quality is by decreasing the amount of scatter that reaches the IR. The air gap technique is a great technique to use when a grid is not being applied. How this air gap technique works is you place the patient at a graded OID, therefore creating an air gap between the IR and the patient. By moving the patient farther from the IR, the patient's still going to produce the same amount of scatter even if they were closer to the IR or farther. The only good thing is that less scatter will reach the film. So this will improve our contrast and therefore give us a good image quality. The only disadvantage about the air gap technique is the fact that we do lose sharpness of the image. Grid frequency is defined as the number of grid lines. Most grids are made with a frequency of 60 to 200 lines per inch. The grid ratio has a high influence on the ability of the grid to improve contrast. As the grid ratio increases, contrast will increase and density will decrease. The grid ratio has no influence on resolution or on distortion. The grid ratio is defined as the height of the lead strips over the interspace. A major disadvantage of using the grid is the fact that as the grid ratio increases, patient dose is going to increase as well because you have to increase your technical factors.